Hello, and welcome to Tech with Shaping Pixel. This time we are bringing you free certification crash course. The AWS Certified CloudOps Engineer Associate Certification Exam, also known as SOA-C03, is designed for cloud operations engineers with at least 1 year of experience in deployment management, troubleshooting, networking, and security on Amazon Web Services. If you're not already subscribed, please subscribe to our YouTube channel. Thorough preparation will help you succeed and earn your AWS Certified CloudOps Engineer Associate credential. Review the official AWS exam guide for detailed task statements and domain weightings. This exam lasts 130 minutes and features 65 multiple choice or multiple response questions. Only 50 questions count toward your score, while 15 are unscored and used for evaluation. There is no penalty for guessing, so always answer every question. The passing score is 720 out of 1,000. The exam covers 5 domains: monitoring, logging, analysis, remediation, and performance optimization, reliability and business continuity, deployment, provisioning, and automation, security and compliance, and networking and content delivery. Each domain tests your skills in areas like configuring metrics with Amazon CloudWatch, implementing backup strategies with AWS Backup, automating deployments using CloudFormation and the AWS Cloud Development Kit, managing security with AWS Identity and Access Management, and optimizing networking with Amazon CloudFront and Route 53. Databases. Amazon Relational Database Service, or RDS, is a managed service from Amazon Web Services that makes it easy to set up, operate, and scale a relational database in the cloud. AWS handles routine tasks like backups and patching for you. With Amazon RDS, you can choose from several popular database engines, including MySQL, MariaDB, PostgreSQL, Amazon Aurora, Oracle, and Microsoft SQL Server. You also select the compute instance type and size, tailoring performance to your workload's needs. For high availability, RDS offers multi-availability zone or multi-AZ deployments. This feature automatically creates a standby database in another availability zone, providing failover protection if your primary instance becomes unavailable. RDS supports storage autoscaling, so your database storage can grow automatically as needed. Most engines use Elastic Block Storage, or EBS, for storage, while Aurora uses a shared cluster storage architecture that scales seamlessly as your data grows. Automatic backups are enabled by default, storing data in Amazon's Simple Storage Service, or S3. You can set retention periods and use the Key Management Service, or KMS, for encryption. Manual snapshots and Aurora's backtrack feature offer additional recovery options. To create an Amazon Relational Database Service, or RDS, database on Amazon Web Services, start at the AWS Management Console, head to the Database category and select RDS, which brings you to the Amazon RDS dashboard. Click Create Database to begin. Choose to create a new database, then select the standard create method for more configuration options. Pick your database engine, such as MySQL, and select your preferred version. For a full feature set, select the production template. Enter a database instance identifier, set your master username, and choose or create a password. Next, pick your instance size from standard classes, selecting the smallest if you want to minimize resources. For storage, general purpose is a good default, and you can enable autoscaling to allow storage to grow as needed. Select your virtual private cloud, or VPC, and decide if your database should be publicly accessible. For private databases, only resources inside the VPC can connect. Assign a security group to control access. Configure backup retention, enable encryption with the AWS Key Management Service, and set up monitoring. Choose a maintenance window and enable deletion protection to prevent accidental loss. Review your settings, then click Create Database. Your RDS instance will launch in just a few minutes. Amazon RDS Proxy is a managed service from Amazon Web Services that acts as a middle layer between your application and your database. It is especially useful for serverless applications, which often create and close many database connections rapidly. In serverless environments, like those using multiple Lambda functions for create, read, update, and delete operations, each function may open its own database connection. This can quickly overwhelm your database, consuming excessive CPU and memory and slowing down your application's response times. RDS Proxy helps by pooling and managing these connections, reducing the load on your database and improving performance. As a managed service, it handles installation, patching, scaling, and maintenance for you. It also boosts security by allowing you to enforce the use of identity and access management credentials and integrate with AWS Secrets Manager, so you do not need to hard-code credentials. Additionally, RDS Proxy increases application availability by automatically rerouting connections if your database fails or switches instances. RDS Proxy is ideal for unpredictable workloads, applications that frequently open and close connections, and those that keep idle connections open for quick responses. Overall, Amazon RDS Proxy streamlines connection management, enhances security, and keeps your applications running smoothly. Multi-AZ, an Amazon Relational Database Service, or RDS, stands for Multi-Availability Zone. This feature is all about resiliency and business continuity, ensuring your database remains available even if something goes wrong in one zone. When you enable Multi-AZ, Amazon RDS automatically creates a secondary database instance, called a replica, in a different availability zone within the same region. This replica is not for handling read-only traffic. Its sole purpose is to provide a failover option if the primary instance fails. If an outage or maintenance affects the primary instance, Amazon Web Services, or AWS, automatically switches to the replica. The domain name system, or DNS, record is updated, and this process usually takes between 60 and 120 seconds, depending on database size and activity. For SQL Server, Multi-AZ uses SQL Server mirroring, which also provides automatic failover, but requires specific configuration. Amazon Aurora, on the other hand, is fault-tolerant by default, but enabling Multi-AZ reduces failover time dramatically, promoting a replica instantly if the primary fails. When failover occurs, RDS triggers an event called RDS Event 025. You can set up notifications via short message service, or SMS, or simple notification service, or SNS, to stay informed and maintain high availability for your applications. Amazon Relational Database Service, or RDS, offers read replicas to help scale your database's read performance. Unlike Multi-Availability Zone, or MAZ deployments, read replicas are not designed for failover or resiliency. Instead, they serve read-only queries from a separate instance. When your primary RDS instance is overwhelmed by read-heavy traffic, you can create a read replica. A snapshot of your database is taken, and a secure asynchronous link is established between the primary and the replica. This allows applications and users to direct read-only queries to the replica, easing the load on the primary database. Read replicas are available for MySQL, MariaDB, and PostgreSQL engines. You can deploy up to 5 read replicas per source database, and even place them in different regions for disaster recovery. With MySQL and MariaDB, you can nest replicas up to 4 layers deep, but this is not possible with PostgreSQL. MySQL requires version 5.6 or later and InnoDB storage. MariaDB supports any version. Monitor synchronization using the Amazon RDS replica lag metric in Amazon CloudWatch to ensure your replicas stay up to date. Restoring a database from an existing backup in Amazon Relational Database Service, or RDS, is a straightforward process, whether you are using automatic backups or manual snapshots. With automatic backups enabled, RDS saves transaction logs to Amazon Simple Storage Service, or S3, every 5 minutes. This means you can restore your database to a specific point in time, but only up to the latest restore time available. For example, if the latest restore time is 1500, you cannot restore to 1502 until the next backup cycle completes. Manual snapshots work differently. When you restore from a manual snapshot, you can only restore to the exact time the snapshot was taken. During the restore, you can change storage types, such as switching from general-purpose SSD to provisioned IOPS, but this may increase restore time. You can also adjust instance size, parameter groups, and security groups, though AWS recommends keeping these settings the same as the snapshot. To restore, select your snapshot in the RDS dashboard, choose Restore Snapshot, and configure your new instance. You can set a new identifier, select a virtual private cloud, adjust storage, and choose availability options. Click Restore Database Instance to begin. Once complete, your new database instance is available, making restoration from backups both quick and flexible. Managing backups for your Amazon Relational Database Service, or RDS, is crucial for protecting your data. But after creating a snapshot, what should you do next to ensure your data is safe and accessible? You can copy RDS snapshots within the same region or to a different Amazon Web Services, or AWS, region. This is useful for disaster recovery or running databases in new locations. Remember, copying an automated snapshot turns it into a manual snapshot. Also, when copying to another region, option and parameter group settings are not transferred, so you will need to recreate them. Amazon RDS Performance Insights is a feature designed to help users understand what is happening inside their databases, no matter their level of database management experience. Traditionally, Amazon CloudWatch was used for monitoring RDS databases. CloudWatch collects metrics from the hypervisor layer, offering between 15 and 18 metrics depending on the database engine. However, these metrics are limited and focus on the instance, not the database engine itself. Enhanced monitoring improved on this by using a lightweight agent to collect over 50 metrics directly from the operating system, even showing processes and threads like the Linux top command. Still, both tools focus on the instance, not the actual database workload. Enhanced monitoring can collect data as frequently as once per second, providing more granular insights than CloudWatch. Yet, it still leaves users piecing together clues from multiple graphs, trying to determine the root cause of performance issues. Performance Insights changes the game by collecting metrics directly from the database engine. Its dashboard in the RDS console visualizes database load, filtering by SQL, user, host, and wait. This condenses complex data into a single actionable metric. With Performance Insights, users no longer play detective. Instead, they get clear, focused insights, making it easier to identify and resolve database performance issues. Amazon RDS Performance Insights helps you understand your database's workload without adding significant overhead. It samples connection data from memory every second, tracking whether each connection is active or idle, and impacts performance by less than 1% of CPU load. Performance Insights collects details about each active connection, including the SQL query, its state, the originating host, and the user. This information is condensed into a single metric called Average Active Sessions, or AAS, which measures database load over time. The Performance Insights dashboard features a load chart displaying recent database load in AAS units, color-coded by weight type. Below, the top activity table highlights the SQL statements, weights, hosts, or users contributing most to the load, ordered by impact. Sampling every second means some fast queries are missed, but this actually reduces noise in the data. Like frames in a video, these samples create a seamless visualization of database activity, balancing clarity with minimal resource use. AAS is calculated by averaging active connections per minute. Regardless of query length or user count, the load chart visualizes overall activity, helping you pinpoint performance bottlenecks and optimize your Amazon RDS database. Active Average Session, or AAS, is a key metric used by Performance Insights to reveal the load on an Amazon Relational Database Service instance. AAS measures session activity, which usually means access to the Central Processing Unit, or CPU. Performance Insights uses color-coded graphs to show what is happening inside your database. Green means a query is using the CPU. Blue shows the query is waiting for disk input or output. Orange highlights when a query is waiting for a database resource, like a lock or buffer. The default graph displays an hour of activity, divided into 1-minute segments. Each segment shows the average active session state for that minute. This makes it easy to spot trends, like constant CPU load or frequent waits for disk or resources. If AAS is near 0, the database is idle. If it is less than the number of CPU cores, the instance is not blocked. But if AAS exceeds the number of CPU cores, sessions must wait, signaling a potential bottleneck. Monitoring AAS helps you understand database performance, spot issues like CPU saturation or disk waits, and make informed decisions about scaling or tuning your database for optimal efficiency. Amazon RDS Performance Insights is a powerful tool for monitoring your database performance. It helps you quickly determine if your database is under load, saving you from unnecessary troubleshooting of application software or network connections. When users report slow performance, Performance Insights shows if the database is the culprit. If the average active sessions, or AAS, is less than 1, the database is not blocked. If AAS exceeds the number of available CPU cores, the database is overloaded, confirming the issue is with the database itself. Performance Insights also helps right-size your RDS instance. If AAS is consistently lower than your CPU core count, your instance may be too large. If AAS is higher, your instance could be too small. Monitoring I/O-based weights can also highlight storage issues. You can access Performance Insights from the Amazon RDS Management Console, either through the menu or the Current Activity column, which visually indicates database load and capacity. Performance Insights data is published to Amazon CloudWatch, where you can set alarms and monitor metrics like DB load CPU, and DB load non-CPU for deeper insights. For advanced users, Performance Insights data is available via a public API and the AWS command line interface, enabling custom dashboards and automated monitoring solutions. Aurora Serverless version 2 is designed to make database management easier by automatically scaling your database instance capacity as your workload changes. This means you only pay for the resources you actually use, eliminating the need for complex capacity planning. Aurora Serverless v2 adjusts your database's capacity by increasing or decreasing Aurora capacity units, or ACUs. The number of ACUs determines how much memory, CPU, and networking your database has. Currently, Aurora Serverless v2 can scale between 0 and 256 ACUs, ensuring your database can handle anything from minimal to heavy workloads. You can set minimum and maximum capacity limits to control your costs. One ACU provides about 2 gigabytes of memory, along with matching CPU and networking resources. If you set your minimum capacity to 0 ACUs, your database can scale down during periods of inactivity, so you only pay for storage, not compute. When a new connection arrives after inactivity, Aurora Serverless v2 will start the database and scale up ACUs to meet demand. This process can take up to 15 seconds, making it ideal for applications that can tolerate a brief startup delay. Amazon DynamoDB is a fully managed NoSQL database from Amazon Web Services, or AWS. Unlike traditional databases that use structured query language, or SQL, DynamoDB is a key value store designed for ultra-high performance at any scale. DynamoDB is popular for gaming, web, mobile, and Internet of Things applications. It delivers single-digit millisecond latency, making it ideal for workloads that demand speed. As a fully managed service, AWS handles all the database administration, backups, and scaling, so you can focus on your application's logic. Setting up a DynamoDB table is simple. Just provide a table name and a primary key. Tables are schemaless, so each item can have different attributes. You can also add secondary indexes to query data by attributes other than the primary key. DynamoDB supports both global and local secondary indexes. You choose between provisioned and on-demand capacity modes. Provision mode lets you reserve specific read and write capacity units, while on-demand mode automatically scales with your workload. AWS charges based on your chosen throughput and storage. DynamoDB is highly available, automatically replicating data across 3 availability zones. However, it has limitations like a maximum record size of 400 kilobytes and eventual consistency for some queries. Monitoring throughput is essential to avoid performance issues. Amazon DynamoDB offers robust backup features to protect your data, similar to Amazon Relational Database Service, or RDS. Let us explore the key backup techniques DynamoDB provides to keep your tables safe and recoverable. DynamoDB supports automatic backups through point-in-time recovery. With a single click in the Amazon Web Services Management Console, you can enable or disable this feature. Once enabled, DynamoDB automatically retains continuous backups for 35 days. This means you can restore your table to any second within that period, providing a strong safety net against accidental or malicious data loss. Unlike RDS, there is no need to set backup retention periods or schedules. DynamoDB handles it all for you. For more control, DynamoDB offers on-demand manual backups. These backups are not limited by the 35-day retention period and remain until you delete them. This is especially useful for meeting compliance or governance requirements. Manual backups do not impact table performance, regardless of database size, and can be created in seconds. You can also schedule recurring backups using Amazon Web Services Backup. Enabling point-in-time recovery or creating a manual backup is simple. Just select your table, choose the backup option, and follow the prompts in the console. With DynamoDB, securing your data is straightforward and flexible, ensuring peace of mind for your database needs. Restoring your Amazon DynamoDB tables from a backup is simple, whether you are using an automatic point-in-time recovery or a manual on-demand backup. Let us walk through the process. To restore from a manual backup, start in the DynamoDB dashboard within the Amazon Web Services Management Console. Select your table, then navigate to the Backup tab. Choose your manual backup, click Restore Backup, and give your new table a name, such as Manual Restore. You can decide to restore the entire table or exclude secondary indexes. You also have the option to restore within the same region or to a different region and to change the encryption type using a key management service key. Once your options are set, click Restore Table. In a few minutes, your new table will appear, fully restored. If you need to recover data lost at a specific moment, use Point-in-Time Recovery. In the Backups tab, select Restore to Point-in-Time. Enter a new table name and pick any restore time between the earliest and latest available dates. Confirm your settings and restore. Your table will be recreated as it was at that exact time. Amazon DynamoDB is a fully managed NoSQL database service from Amazon Web Services, or AWS. With DynamoDB, there is no need for database administration, server management, or backups. You simply set up your tables and configure the provision throughput, while AWS handles the rest, including replication across multiple availability zones for high availability. DynamoDB is designed for speed, delivering read and write operations in just milliseconds, regardless of table size. However, because data is replicated across zones, some queries may return older data due to eventual consistency. For most applications, this is seamless, but certain use cases may require even faster, more consistent reads. This is where DynamoDB Accelerator, or DAX, comes in. DAX is an in-memory cache that boosts DynamoDB's performance up to 10 times, reducing response times from milliseconds to microseconds. It is fully managed by AWS and integrates seamlessly with existing DynamoDB applications. DAX can handle millions of requests per second, supports clusters with up to 10 nodes, and reduces DynamoDB read capacity needs, lowering costs. It is fully compliant with DynamoDB API calls, requiring no changes to your application logic. DAX clusters reside within your virtual private cloud, or VPC, and support encryption at rest using the Advanced Encryption Standard and AWS Key Management Service. Application performance is more than just a technical concern. It directly affects your business's bottom line, influencing everything from revenue to customer loyalty and even your brand's reputation. Studies consistently show that delays in web and application performance can hurt key business metrics. For example, a 2017 study by Strangeloop found that just a 1-second delay in page load time leads to a 7% loss in conversions, 11% fewer page views, and a 16% decrease in customer satisfaction. When applications are unavailable, businesses not only lose revenue, but also risk damaging customer trust and their public image. On the other hand, improving performance pays off. Shopzilla, for instance, reduced their site load time from 6 seconds to 1.2 seconds, resulting in a 12% increase in revenue and 25% more page views. Ultimately, every second counts. Investing in application performance is investing in your business's success and customer satisfaction. Caching is a powerful technique that can dramatically improve application performance. By adding a high-speed data layer between your applications and their data stores, caching helps deliver information much faster than traditional methods like database queries or disk access. The core idea behind caching is simple. Store frequently accessed datasets in memory. This allows applications to retrieve data at lightning speed, since in-memory access is at least 50 times faster than disk access. Latency drops from milliseconds to microseconds, making a noticeable difference. Implementing a caching solution brings several advantages. Not only does it boost performance, but it also enhances resiliency and scalability. Caching helps manage the size of databases and application instances, ensuring your systems can handle more users and data without slowing down. Many large-scale applications, such as social media platforms, gaming services, media sharing sites, and news outlets, rely heavily on caching. For example, Amazon Elasticache stores strategic datasets in memory, improving latency and throughput for read-heavy workloads. In high-performance computing, where massive datasets must be accessed quickly across multiple nodes, an in-memory data layer is essential. Disk-based access simply cannot keep up, making caching the only viable solution for these demanding scenarios. Amazon Elasticache is a web service designed to make deploying and operating an in-memory cache simple. It automates tasks like provisioning machines, installing software, patching, failure detection, and recovery, so you can focus on your application's performance. Elasticache creates an in-memory data layer between your applications and data stores, accelerating read operations. It integrates with services like Amazon EC2, Amazon RDS, CloudFormation, Elastic Beanstalk, and AWS OpsWorks. Monitoring metrics are sent to Amazon CloudWatch, helping you quickly evaluate and diagnose issues. Elasticache supports two key value in-memory engines, Memcached and Redis. Memcached is multi-threaded, leverages large multi-core instances, and is widely used as a caching solution without persistence. Redis, on the other hand, supports complex datasets, disk persistence, and can be deployed across multiple availability zones with automatic failover. You can scale your cache clusters by adding or removing nodes as your application needs change. Elasticache from Memcached includes AWS discovery and automatic node replacement, making it easy to manage clusters even during workload spikes. Elasticache for Redis supports role-based access controls and encryption, meaning compliance standards like PCI DSS, HIPAA, and FedRAMP. This makes it suitable for applications with strict security requirements. That's all in this video. Let's see you in the next part. If you're not already subscribed, please subscribe to our YouTube channel. Thanks. For all the latest real exam question and answers and more content, please visit our website, www.shapingpixel.com.